for today's video, we will discuss a modern CPU architecture. So CPU are everywhere. CPU in laptop, in the machine that check the product of the grocery store, the computer, especially powered instrument in our car. So what is CPU? CPU or Central Processing Unit. It is the center of everything in the computer. It handles all the computation needed to turn input from memory, like photo on your hard drive, into output on your peripheral, like an image on your monitor. So next is a Moore's Law. Moore's Law by Gordon Moore. This ability to continue stringing transistor is based on a famous law or observation that we in industry refer to as Moore's Law. It also based on observed trend showing what we can double the number of transistor per unit area about 2 years. This simple law drives tremendous innovation, making what was once true to be impossible not only possible but also cheaper over time. Robert Noyce. In 1959, Robert Noyce patented the first monolithic integrated circuit which combined multiple transistors on a single silicon chip. This early chip didn't have many transistors, but they enable much smaller and more complex circuit design. Next is the ENIAC or Electronic Numerical Integrator and Computer. Were built using vacuum tube technology which made them a huge and unreliable at the birth of digital computing. Computers were fragile, slow, and large and gigantic. ENIAC, the first general-purpose digital computer from 1946, covered 1,800 meters squared. Intel on early years. So as you can see the evolution of Intel from 1971 with Intel 4004 until 1979 with Intel 8088 and the 11th gen Intel Core processor named Tiger Lake. John von Neumann. In late 1940, prominent mathematician popularized a new kind of computer architecture that simplified computer design and programming. His idea for a stored program computer reimagined the general-purpose computer as three separate systems: a main memory, two CPU, and two input and output. The ISA or Instruction Set Architecture. The Instruction Set Architecture is a set of instructions that defines what kind of operations can be performed in hardware. It is nothing more than the language of computer. The ISA or Instruction Set Architecture is the dictionary of instruction, data types, and the formats that the CPU adhering to that ISA must execute. Microarchitecture. A microarchitecture is an implementation or specific design of instruction set architecture. It also introduced the four-step instruction cycle: the fetch, decode, execute, and write back. Fetching instruction from memory, decoding the instruction, executing the instruction, and storing the result back in memory. CPU pipeline. A CPU pipeline is asynchronous, and what we mean by that is each pipeline is controlled by a clock and each data goes from one pipeline stage to the next as a CPU clock completes a cycle. Speculative execution. Modern CPU architecture can often predict branches with a near-perfect accuracy that makes them seem almost clairvoyant. Superscalar execution. A basic ALU or arithmetic logic unit can perform operation like adds and subtracts. If we have a single ALU, this means we can do one add at a time, which is referred to as scalar execution. Modern microprocessors now implement many ALU, and when those ALU can operate in parallel, this is called a superscalar execution. Register renaming. A register renaming is a form of pipelining that deals with data dependence between instructions by renaming their register operands. An assembly language programmer or an compiler specify this operand using architectural register, the register that are implicit in the instruction set of architecture. Time goes by, our CPU evolves and updated, or let's just say high-tech. That ends my video. Thank you for watching.